Alright, Honda Tech, take number 8. Hopefully nothing goes wrong this time, because I'm starting to get annoyed. This is my Holset HE351VE variable geometry turbo. Basically what I'm going to discuss in this video is two internet misconceptions and a viable method of controlling the variable geometry vane without using Holset's little magical box that no one has been able to use thus far. And let me preface all this by saying that since I am building a Honda at this point in time, that I don't think a chip P28 with any aftermarket software will be able to handle just the logic needed and all the different input variables versus output variables. I don't think it can do it. I'm running an AAM EMS, boom, so I have a lot of control over functions, a lot more so than a stock software-based ECU. Now, the internet misconceptions. The HX series and the HY series all have silencer rings above the ported shroud assembly on the inlet side of the compressor cover. Those simply remove with a snap ring, a very big snap ring. On this turbo, there are normally 3 pins that are pressed through the housing that are here, here, and here. You can tell because I removed them. And these people have been saying if you drill those 3 pins, you can remove the silencer ring. Well, I did that, and they were wrong. It's cast as one piece, so I don't recommend drilling the pins. If you want to remove the silencer ring that bad, do it on the turbo. I mean, just take a Dremel tool or a cutoff wheel and go around the diameter like so, and boom, it's off. But I wouldn't bother with it. Also, people have been confused as to, hey, what type of drain flange do I get? Well, what we have here is a standard T3, T4 billet drain flange that's 1/2 inch MPT. That's what it's threaded for. The holes lined up perfectly, centered, and the actual drain hole is centered on the flange as well. So if you're wondering what kind of drain flange you're on your project, boom, T3, T4 works without a problem. That's just a limit ring that goes in the housing like so, just to keep the vane from overextending. Flip it one more time. The inlet fitting, which is here, don't get it confused. This right here, that's where the shaft sensor goes in the housing. This is 12 by 1.5. It's metric, and everyone's been saying that they can't find a 3AN fitting in that thread pitch. So they've all been running 4 and adapting it down to 3. I don't know where they searched, but it took me 5 seconds to find a 3AN 12 by 1.5 fitting. And if you can almost kind of see there's a restrictor of sorts in the turbo. It's pretty big. It's almost 1/4 inch in diameter versus the inlet hole. No one really knows what this turbo likes as far as pressure and flow. No one's ever really blown one up. They go for hundreds of thousands of miles on trucks, so I guess as long as you feed it oil, it's happy. The coolant, feeding this turbo coolant is a little tricky in and of itself, because the control unit right here, these 2 holes here are coolant passages, and actually this one's right off the main feed, and basically they use it to keep the control unit cool, because it does have a PCB inside of it with an electric motor. So some people don't run coolant I prefer to, so I'll have to figure out some clever method of bridging these two holes. It'll probably be, you know, welding a couple fittings on. I don't know. I haven't gotten to that point yet. But all right, back to the topic. How do we control this vane system reliably with repeatable results? Well, the DSM guys have been using just simply an internal wastegate actuator. Most of them use their old 14B actuators. And I mean, it works. It will open the vanes. This wastegate does have enough travel to do so. Most of the DSM guys haven't gotten to the point of running a boost controller on this circuit. They simply let spring pressure open the wastegate. So if the wastegate's set at 7 pounds, it opens when the turbo makes 7 pounds, and it goes from there. The problem that they're having is on high boost pulls, high RPM pulls, when they let off the throttle and that wastegate retracts because it sees vacuum, the vanes go from this to this in about a fraction of a second. And basically, when this vane is out like this, it makes the housing 2 centimeters. That's very, very small. And they say it's like hitting a brick wall. Car decelerates so hard. And they say driving around with the vanes closed, they said they get horrible fuel efficiency. It runs like crap. One guy said the cool part was it sounded like a jet engine. I don't care what my car sounds like as long as it gets good fuel economy while I'm driving it, even in boost. Fully open though, it's a 25 centimeter housing, much better for highway cruising RPM, low throttle around town kind of stuff. So, like I said, my ECU will be reading the shaft speed of the turbo itself, back pressure in the exhaust manifold, load on the engine, and we'll generate some sort of map in the AAM that's adjustable, that will dictate, you know, hey, above a certain throttle load, we need to start shutting the vanes to make boost. And then really the trick is when to open them. Because if you leave them closed too long, you can affect power and torque production. But if you open them too soon, you've got lag, you've got car that's not fun to drive, because this is a fairly large turbo in the world of small displacement motors like Hondas and Acuras and DSMs and Evos and things of that nature. So my system at first will utilize an internal wastegate. The difference being, well, this is just one I had laying around. I will be using a dual port just so I can get some slightly better control over how it travels. But I will more than likely be fitting it to that hole right there. I'll probably just take it to the shop and press a pin in that's a similar diameter, because I am going to I'm going to cut the leftmost edge off of this actuator, making it kind of like well, I can't really describe it, but it'll be cut off enough that it can still grab this pin and move the vanes forward and open them. And for you know, out of boost, around town, low RPM, highway cruising, stuff like that, you need to open the vanes. Well, unless you have an onboard air supply that you can feed to the wastegate, it's not going to do anything. So I happen to luck out. This little guy right here, you can see it, there we go, came off my ITBs for my project that just happened to be off a BMW motorcycle. It's like a 2006 K1200R Sport, and they have traction control. And what this does in that application is it bolts to a cam on the throttle body, and if the ECU detects wheel slip, this extends, and it travels like 1.75 inches, so it moves quite a ways. And it's a geared configuration or a screw type, so it's got enough torque behind it to move this actuator. So the whole idea is, excuse me, is let's say that under 50% throttle and such an engine load, this extends and opens the vanes. So while you're cruising down the highway, you get maximum economy, low back pressure, lower shaft speeds on the turbo, and there will be some sort of, obviously I'll have to have bracketry to mount all this. I'm still working that part out, and I will be using a return spring of some sort. I'm still working on that as well. I need to figure out something that has enough tension that when I back the actuator off, that it has enough tension to close the vanes, but not cause an issue for the wastegate opening them. And if I can refine this system enough, I'm hoping that we can get rid of the wastegate itself and simply rely on this actuator and a return spring, because this is on a pulse width modulated circuit, so it doesn't have to be fully open. I can have it open halfway, quarter way, third of the way, so if I can dial this setup in enough, I can have this one single little actuator precisely control vane movement and position throughout the RPM and engine load range. At least that's the goal. I might get all this together and fail horribly, but at least I tried. So I mean, that's pretty much it. Comments, criticism, advice, help, it's all welcomed. Hopefully I'll be able to work on this a little bit more here soon. I mean, hell, the car doesn't run still, so I gotta fix the car too. But that's my idea, and I'll be doing something special with the compressor cover. Since this is already out, I got something special in mind. I just gotta confer with my buddy and draw something up in SolidWorks. But yeah, give me your advice. Tell me what you think. Thanks.